So do you remember a while ago when we did that funny little clip of NVIDIA just pushing AMD down before the fight ever got started? I feel like in this fight, we've got a little bit of a revision to that we have to make. So for those of you that I know are probably not going to watch the entire review and are just going to skip ahead, let me just go ahead and give you the too long didn't watch. Intel wasn't ready. Normally, I would tell you all about how World of Warships is a multiplayer online game that's absolutely free to play with millions of players, that you get to take control of some of the most iconic warships in world history, and how the graphics are beautiful and has a completely revamped graphics engine and all sorts of different play styles. But I got something more important to tell you about today. New players that sign up using my link in the description below are gonna get a pretty awesome starter pack. You'll get 700 doubloons, 1 million credits, 7 days of premium time, the Japanese ship Ishizuchi, and the USS Charleston. Now with that pack, you'll get off to a pretty good start, but not good enough to take me on. So now that I'm done with this ad, I'm gonna go back to playing World of Warships while you go ahead and watch this video. All right, so AMD's 5000 series CPUs built on AMD's brand new Zen 3 architecture. We got a few things to talk about here. We've got some gaming benchmarks, we got some CPU benchmarks. It's interesting, CPU testing is always really difficult. And the reason for that is a lot of things have been offloaded to GPUs these days. A lot of people have leveraged GPU performance and don't do a whole lot of things on CPU anymore. So a lot of the tests that you're seeing right here are tests that could also be done on GPU, but we need a way to compare them. So obviously we're talking about AMD versus Intel, because that's the only two players in the game right now. And it quite honestly seems like one of these players didn't really show up to the game, if you want to know the truth. This is so much fun, actually. I love when a big upset like this happens. 2017, Ryzen came, and Intel made a statement. Yeah, but the CPU's just glued. It's just glued together. It's just glue. Well, I wish Intel would glue something together at this point. Maybe something lower than 14 nanometer plus cubed. I mean, I'm telling you right now, it's a little embarrassing that Intel is sending out emails and blog posts and all these things, quite literally doing damage control, trying to get people to remember that they still are around and they still exist. Because the whole glue that they talked about is how we got to where we are today with AMD. And I'm not gonna do a deep dive into the architecture, but what I am gonna talk about is some of the changes that they made, which is why we're seeing such massive IPC improvements as well as massive just overall improvements. The glue they're referring to is the Infinity Fabric. And the Infinity Fabric is just the interconnect between the chiplets. Now AMD has really invested into this whole chiplet design, where you have basically a core structure, and then you have a cache that's shared between them. And then you can scale up or down the size of the CPU based on how many of those components that you basically stack up inside the CPU. So, or inside the entire substrate, I should say. And so that is the glue that Intel is referring to, saying it's glued. Now, the irony is that they've been gluing Xeon CPUs in that very same way for a while, actually. So the glue that Intel is referring to is the Infinity Fabric, and that's the way that the interconnect works between the chiplet designs. So what AMD has effectively done has allowed them to have almost like an infinite scaling. Infinity Fabric, okay, not related, but almost an infinite scaling, in that you could have your basic 4-core, 4-thread CPUs like you saw back in Zen 1, which is just 4 cores in a single chiplet. Or like Threadripper, where they just have a ton of them going down the entire substrate, all having their own interconnects and L3 cache and all that sort of stuff. The problem with that was, the way the design initially was Zen 1 and Zen 1.5, although 1.5 they really increased the bandwidth and the bus between the chiplets, was the fact that L3 cache was divided. So you would have the different cores accessing their L3 cache, but they didn't have access to the entire amount of the L3 cache. And that unfortunately created a lot of latency and a lot of trade-off in the way that cache gets refreshed, especially when you hand off from one CCX to another. Now CCX is just basically those chiplets that are all created on this one little city of CPUs, if you will, or cores. That's referred to as a CCX. The L3 cache was the limiting factor in terms of the bandwidth and the overall speed of the CPU. So what has happened here with Zen 3 is we've seen now 8 cores per CCX and the entire amount of L3 cache per CCX. So now you're getting full access to the entire cache. And that's one of the ways that we're seeing the improvements that we're seeing with especially IPC, because now you have a much fatter pipeline happening between them. The Infinity Fabric design continues to improve in terms of reducing latency between the CCXs. And then just, well, I guess the manufacturing process just getting better as a whole. Because remember, they are on TSMC's 7 nanometer. Let's just go ahead and show you guys the benchmarks now that you kind of understand what sort of changed over time. What we're comparing right here is the Intel 10900K to the AMD 5900X and 5950X. And the reason why we're not showing a 10700K here is because of the fact that basically the 5900X and the 10900K are almost dollar for dollar comparable. And then the 5950X being really the best offering on mainstream CPUs right now. So let's go ahead and show you guys those benchmarks, which realistically just looks like a digital version of a prison yard beatdown. So there's something funny to talk about with this chart. You guys, I mean, okay, it's just sad, honestly. It shows that Intel's aging 14 nanometer process is just that, old and tired. And even though it has a clock speed advantage, it is obvious with the IPC improvements that I almost said Intel, God, things I'm used to saying. With the IPC improvements that AMD has pulled out with its manufacturing process, with the bumping clock speed, because that's the thing I said during all the previous Zen launches. They need clock speed to go with this IPC. Well, they've got it now. Because here's the thing, the 5900X goes 4.3 all-core turbo clock. The Intel goes 4.7 to 4.8 all-core turbo clock. The 5950X also is 4.3, at least that's what ours was doing. And it has up to a 4.9 gigahertz single core performance, as well as the 5900X having a 4.8. So now you take and let's talk about the way these clock behaviors behave. First of all, up to is a very important statement to see when you read about these clock speeds on the box and it says up to. The 5950X says up to 4.9 gigahertz, but I observed more than 4.9 many times, even it hitting 4.97. The other thing to mention here is even though the 10900K says up to 5.3 gigahertz, it rarely stays there. It spends a lot more time around 5.1, 5.2 on single-threaded performance. Now, the single-threaded performance doesn't have to deal with the whole turbo timer that you get on Intel's 10th gen. However, anything all-core that takes longer than 56 seconds does then immediately start to turbo down. Now, yes, these are functions that you can go in and mess around with on Intel to keep the clock speeds up. However, it's obvious that we didn't do that with any of these systems because this is the out-of-the-box testing that we do. And if we were to do that on Intel, there are tweaks and stuff we can do on AMD to give it the same type of benefit. So what you saw here is 100% out-of-the-box performance plopped into an ASUS motherboard and an MSI motherboard, both of these being top-tier class motherboards in their respective genres here in terms of AMD and Intel. No sort of shenanigans happening with the Asus or the MSI trying to do any sort of turbo clocking or overclocking or turbo timers. Everything was set to their factory defaults for the CPU. Remember, there's a difference between Asus factory default and Intel factory default. So we made sure that all those things were properly set. So not only did we see a stupid amount of IPC improvement when we took the clock speeds, locked them at 4 gigahertz, and then did a single core test. When you take a look at the IPC test, it's just sad. I mean, we're talking 100 points difference between the 5950X and the 10900K core for core at 4 gigahertz. And then it was only 1 point lower on the 5900X. That's because they're the same core. That's just margin of error, that 1 point. We were seeing the 4 gigahertz locked IPC test barely being behind the Intel unlocked test. What do I mean by that? Well, the Intel single core Cinebench R20 run was a score of 526, and that's with it being allowed to boost up to 5.3. But when we locked AMD at 4 gigahertz, it was a 518 and a 519. I mean, that's how far Zen has come. But when it comes to gaming though, we tested 1080p and 1440 because we need to see what happens with the bottlenecks. So what we did to basically make this a level playing field is we took the same MSI Gaming X Trio RTX 3090 and put them on each bench. We did not use 2 identical cards because those cards can have variance between themselves, so that wouldn't be a very fair test. We maxed the boost clock, or not the boost clock, but we maxed the fan curve, 100% fans. We maxed the power limit and we maxed the temperature limit to reduce any sort of P-state changes. That way it'll hit the maximum boost table. And then we did our gaming tests at a mixture of high and medium settings, artificially bumping up the FPS because at 1080p, more FPS, any sort of CPU bottleneck is going to show. We also did 1440p, that way we could see what happens when you step up the resolution, because although 1080p is the dominant resolution in the Steam survey, I have a hard time believing anyone that would have an RTX 3090 and a 5950X, 5900X, or even a 10900K is going to have a basic 1080p panel. So you might be running 1080p high refresh rate, but 1440p now is so much more affordable. I have to believe people with this level of hardware would probably be running something higher than 1080p. The but that I mentioned earlier, but you give up some FPS in gaming, is now applied to Intel. Because Intel across the board at 1080p was lower FPS. Now, Far Cry 5 is a title worth mentioning here though. They're very similar. But that's a very CPU-bound title, and that's one reason why we like it, because it does a lot of CPU physics happening alongside the test. So the CPU being loaded by having to do something besides just throw ping pong balls at a wall, as the world thread, it actually has to do stuff. 166 to 177 FPS of the 5900X, 180 with the 5950. And the reason why we saw such a big bump with 5950 there is because of the fact that, again, CPU test. Now it's worth mentioning though, certain titles, even though we're only showing 3 right here, do have a slightly higher minimum FPS on Intel, but a higher average and a higher max to be found on AMD sometimes. So they're very close in terms of that performance, min-max, but the average is higher on AMD. That's not something I was really expecting going into this. Now there's one other thing worth talking about here that I think surprised me. When I first set this up, I'm going through my tests and I'm seeing the Blender score and I'm seeing the Cinebench score and I'm seeing the Fishy Cat and all that sort of stuff. I was like, man, I was expecting a little bit more performance out of 5950. It's not bad. It's beating the Intel for sure. I was like, but at $250 more, $250 more, I was expecting a bigger gap. And Phil and I were talking about this, and then I looked at the boxes, and then I realized the 5950X was still in the box. And I went, wait, was this the 5900X the entire time? And it was. So the huge gaps we saw were the 5900X versus Intel at the same price. Yes, I'm aware it has 2 more cores and 4 more threads. However, the most directly comparable spec you can possibly ever test is price, and that's exactly how these two stack up. I have to imagine though that a 10-core 20 thread with the same clock speeds and the same IPC is still gonna beat this Intel in all of those tests. I have no reason to believe it wouldn't. So once we put the 5950X on there, then we saw, holy cow, this is like a pod boss beating down a newcomer. Prison talk, okay? I'm hardened. I'm a hardened CPU tester. Shut up, stop laughing at me, Phil. I've been watching 60 Days In, okay? Intel just got rolled out.
What'd you get in for?
But Intel. There is an anomaly worth talking about here though. Premiere and some games just, we've known this though for a fact, especially for a while now, even with X299 and Threadripper, not a lot of games like a lot of cores. So we think what's happening here with the 16 core, 32 thread 5950X, yeah, 16 cores, 32 threads on that substrate. Remember how big those had to be in the past? Now you're getting that at way less than Threadripper cost when it first came out, and don't put that against the 1950, because the Threadripper owner will just cry themselves to sleep for a week straight if you compare the price and the performance 4 or 5 years later. Premiere, for some reason, was slower. The 5950X was slower at Premiere. We're not too sure why, and we think that that's Adobe being Adobe. Anyone that uses Adobe products on a regular basis just knows what Adobeing means, okay? And it is what it is. In terms of games, same thing. Not all games like a lot of cores. The 5900X is quite honestly the best CPU we feel you could possibly buy right now at this time and day for gaming, content creation, productivity, value. It's all there. Everything anyone, in my opinion, has ever asked for and wanted in a CPU is there, because before you had to make that trade-off, gaming or multi-threading. There's no point. There's no reason. I built that thing back there, and I'm telling you right now, I'm conflicted. It's got a 10900K, and I know for a fact, if I throw the 5900X in there and redo that system, it will go to waste because I don't use it. I want to build myself a new system for the office with something out of that CPU that's got a cool theme or something going on to it. Because I've got a Threadripper system in there now that's also going to waste. But I can't in good conscience take this CPU and throw it in my personal gaming rig, which I know won't get the use that it deserves. So I'm okay with leaving Intel in there. I made a prediction that these were probably going to be faster and it would go to waste if I put it in there, and that's absolutely true. I now know I'm leaving a little bit of performance on the table with the 3090 being in there. But at the end of the day, it is what it is. AMD is top dog. Intel, I don't believe has an answer. You know why? Because the most recent statement said their 11th gen is 10 nanometer ported back to 14 plus. What the frick does that even mean?